Okay, so in this video, we're going to continue talking about how to find vertical asymptotes. But we're going to focus on this idea of holes, finding holes. Okay, so this is a good example to show what a hole is. So f of x equals x over x. Now you might say, hey, isn't that just f of x equals 1? Well, it's a little different than f of x equals 1 because if f of x equals x over x, then the domain for this would be, all values except 0, right? X can't equal 0. So the domain would be negative infinity to 0, 0 to infinity, right? You can't have 0 on the bottom of a fraction, so this would be the domain. So if you were to graph this, right, super easy to graph because f of x, it does equal 1 for all values except for when x equals 0. At x equals 0, there is an open hole there. So the value is 1 for all the other x values, right? If you plug in negative 1, negative 2, you'll have negative 2 over negative 2, which is 1. If you plug in negative 1 over negative 1, which is 1. If you plug in 1 over 1 is 1. 2 over 2 is 1. So you always have f of x is always going to equal 1 except for when x equals 0. Then there will be a hole, right? So this is the hole. Okay, so there is no vertical asymptote for this function. So there's no vertical asymptote. Rather, there is a hole. Okay, so there's no vertical asymptote. There is a hole at, well, what is this hole? X equals 0 and y equals 1. So, there's a hole there. Okay, so now let's do another example where we're going to have to be careful about finding holes, right? So if we were to first start by finding the domain of this function, we would say, okay, well, x squared minus 16, I set that equal to 0, and then that is x, let me erase that actually, because we could just add 16 to both sides. So we'll get x squared equals 16, and then x equals plus or minus 4, and then x equal, then my domain then, so if you were to say, okay, so here's my domain is negative infinity to negative 4, right? Can't equal negative 4, and then negative 4 to positive 4 can't equal 4 to infinity. Okay, so that would be my domain. Now, you can't just say, okay, well, so, my vertical asymptotes are x equals negative 4 and x equals 4. If you do that, you are going to have made a mistake because one of these values is not a vertical asymptote, rather it's just a point where there's a hole. So this is not the right answer. So to find holes, the best way to start is actually first make sure that you factor both the top and the bottom. So if you start by factoring the top and the bottom of your function, you're going to have better luck in not mistaking a hole for a vertical asymptote. So I'm going to go ahead and do this down here. So f of x equals x plus 4 over x squared minus 16. Okay, so that's the same as x plus 4 over x minus 4, x plus 4, right? I just factored x squared minus 16. It can be factored like this, right? Because this is basically, a squared minus b squared, and that's a minus b times a plus b, right? That's like a rule. Okay, so now you see that this cancels with that. Right? I mean, you still have to consider when you cancel those, you have to say, oh, x cannot equal negative 4. And you have to remember that that's part of your domain, okay? So then this is 1 over x minus 4. All right? And, as long as you remember x cannot equal negative 4, this is what f of x also equals. Right? So, just like how in the previous example, f of x is x over x, it's the same thing as saying f of x equals 1, x cannot equal 0. You know, those are two equivalent statements. All right, so this is equivalent, and so you'd see now that x equaling -4, this is the whole. All right, and your vertical asymptote is when x minus 4 is 0, so that would be when x equals +4. Okay, and so that's your answer. That is your vertical asymptote.